Okay, we're looking at section 6.1. Additional topics in trigonometry is the title of this chapter. 6.1 is the law of sines. So we are going to try and solve triangles that are not right triangles. The SOHCAHTOA is good for right triangles, but what about other types of triangles? Triangles that are acute or obtuse? Well, we could call those oblique triangles. If they're not a right triangle, we could call them oblique triangles. But you need to know the measure of at least one side and any two other parts. So you could have one side plus two other sides, or you could have one side, another side, and an angle. So you have to have at least one side and then two other parts. So that means you could have two sides, two angles, or one side and one angle, in addition to the first side that you know. This leads us to four cases. Okay, what are our four cases? You could know two angles at any side. That would be like AAS situation or ASA. Don't worry, we're not proving anything, we're not proving triangles or anything like that. Or you could have two sides and the angle opposite one of them. That would be like an SSA situation. That's like if I have a triangle here, I have a triangle here, and I know this side is 6, and I know this side is 8, and I know not the angle in between, but the angle opposite one. Like I know this angle is 28 degrees. Then that would be this second case, right? I could know all three sides, or last case would be two sides and their included angle. That's if I had, let's say, the same picture. This is 6, this is 8, but I happen to know that this angle here is 63 degrees, right? I know the included angle. That's a different case. So there's four different cases, all right? And it turns out that law of sines works for case 1 and case 2, but is absolutely no help at all if you're at case 3 or case 4. So if it's case 3 or case 4, we need to use the law of cosines. Stay tuned, that's section 6.2. All right, so for right now, here's the law of sines. Jacob.
Do we need to know those situations?
I would think if you see a situation, I would try law of sines first because it's easier, and when you say, oh, wait, this won't work, then you go to law of cosines.
But we don't have to
I don't think you need to know. Okay. I don't think you need to know those individual cases. Okay, so here's the law of sines. If you've got triangle ABC, right? So the vertices are capital A, capital B, capital C, and the sides are lengths A, B, and C, lowercase, and side A is always across from angle A, side B is across from angle B, and so on, right? Then this is what the law of sines looks like. Not a very difficult, rule. It's just the sine of angle A divided by side A is equal to the sine of angle B over side B, and that has to be equal to the ratio of the sine of angle C over sine C. That's it. That's the law of sines.
The side that goes with the angle listed is opposite the angle?
Correct. So the lowercase a is always the side length that's across from angle A, and so on. Okay, so let's take a look at this, not that, or that, or that, or that, or that. Here we go, example 1. All right, so angle A, let's say, is 30 degrees. I'm going to make this, I'm just going to call this angle A right here. Let's say this is 30 degrees. And side A is 32, so I know I have to put that across from it. So this side here is 32 feet. And angle B, let's say, is 45. I'm just going to call this angle B here, and that means this is going to be angle C. And if angle B is 45 degrees here, for example, we are going to try and solve this triangle. Okay, so let's list what we know. We know A is 30 degrees, B is 45 degrees. We don't know angle C yet. And then we're trying to find side A, side B, side C, and all I know is that side A is 32. Can we find this last angle?
Yes.
We don't need law of sines to do that. What's that going to be, Josh?
Just do 30 plus 45 and then subtract that from 180.
Okay, so 180 minus 75 gives us what? 105. All right, are we okay with this? All right, at this point, we're going to use law of sines to find the missing two side lengths. So we are going to say did start this recorder, didn't I? Just checking. Oh, we're all good. Okay. I was laughing, I was throwing out Smarties, I didn't know what I said. Okay, anyway, so in this case, I will say sine of angle A over A equals sine of angle B over B. Let's start with just that piece of the law of sines. So we're filling in sine of 30 degrees over side A, which was 32, has to equal the sine of angle B, which was 45 degrees, over side B. And we're solving for side B. Grab your calculator. We're going to cross multiply and solve for B. All right. So we're taking this times this equals this times this. I'm going to write it out over here. Somewhere. How am I going to write it? So I get sine of 30 degrees times B is equal to 32 times the sine of 45 degrees. I'm dividing both sides by sine of 30. And I would just do the whole thing on the calculator and get a decimal answer for this, okay? So what does this turn out to be? We need 32 times sine of 45 over the sine of 30. I know that these, I happen to pick angles that are on the unit circle, but let's just use the calculator, which I don't have loaded, which makes me sad. But you're racing me and you're getting the answer, right? I got it. You got it? What'd you get?
45.25.
5.2?
45.25.
45?
45.25.
45.25. Do people agree with that? Okay, so if this turns out to be,
You guys disagree?
yeah. You disagree?
Hit the degree bar.
It can't be a degree measure though, can it?
No, you gotta use the degrees for.
Close.
Yeah, I used the
Um,
degree, I got 4.8.
So it's 32 over sine of 45. Oh my gosh. Menu, calculator, fraction template. So I want 32 times sine of 45, is that right? And I got to push the degree button because I know I'm in radians. Divided by, I want sine of what? Sine of 30, push my degree button. And I want a decimal approximation for this. I'm getting 45.25, right? Are we okay with this? So if this is 45.25, that's what I can fill in here, 45.25. Agreed? What's wrong? You didn't like that?
Well, isn't it? Yes? I want to say a fraction.
Because you got to divide by sine of 30,
Okay.
right? But
But
it's
it
not
should
the
be
same.
to work, right? Even if I just want that way. Well, I just found out the signs first and then divided.
That should still work. Okay, at this point, let's find angle, or side C. So we're going to do sine of A over A equals sine of angle C over C, right? So we're going to do sine of 30 degrees over 32 equaling the sine of 105 degrees over C. You're going to cross multiply and solve, correct?
Ms. President,
Yes.
would you do sine of B over B?
You could use the B, the side B that you found. I'd probably go back to the given one, but it's up to you. So I think we end up getting C equaling 32 times sine of 105 over sine of 30. Does everybody agree with that?
Yeah.
Okay, so really, I'm not going to retype this whole thing. I'm going to be strategic about this. I really only want to go up click, enter this, and I just need to edit this and make this 105. Would you agree with that? Are you getting 61.8? Okay, I wouldn't retype it. I would just do that. So 61.8 gets us the last side that we needed. Are we okay with this? Okay, so that brings up example 2. Because of prevailing winds, a tree grew so that it was leaning 6 degrees from vertical. At a point 30 meters from the tree, the angle of elevation to the top of the tree is 22.5 degrees. So you are asked to find the height of the tree.
Okay.
Okay? So, and by the height of the tree, I think we're talking about like this height here, right? That's the height. Okay, so this is 22.5 degrees here, and we're 30 meters away from the base of the tree. Would you agree with that information?
Mhm.
Okay, but we also need to know this, we need to know one other piece, and they only told us that 6 degrees is leaning 6 degrees from vertical. Jacob,
Wouldn't it be 84 degrees then?
what's going to be 84?
The angle up at the,
Well, let me label this. I'll call this A,
Yeah.
this B, this C. So what angle are you talking about?
that should be B, right?
Is B going to be
No,
96.
96.
96? All
I
right,
was
it was-
subtracting instead of adding.
all right, so this little angle here is 6, but this angle is a right angle. So I think we really want this to be 96. Do you agree with
I
that?
was just going the wrong way.
Are we okay with this? All right, so at this point, how are we going to set up and solve for H using the law of sines? And time for me to call. Danny,
Okay, so I found the value of the angle C.
okay.
which
So
was
what's C going to equal?
61.5.
So A is 22.5, B is 96, so you got C to be what?
61.5.
61.5, do people agree with that? Okay, and then we know that side A, we don't know A. We know side B, no we don't, we're trying to find that. No, we're not, we're trying to find C.
We're trying to find side A.
Oh, right, because that's what I'm calling H,
Yes.
right? Okay, and so we know what side, C is third, does that look right? Okay, so how are we setting up this, Katie?
I just have a real quick question.
Yeah.
What did we do with the 6 degrees? I don't see all that.
What did we do with it?
Yeah, like, I don't understand.
We said that that's how we got this 96-degree angle here, because we said if it's leaning 6 degrees
Oh,
from
okay, so
vertical,
that's what the.
and that's a right,
Okay.
right? So it's
Yeah.
90 plus 6 is what gave us the 96.
Okay.
All right? Okay, Alexis, set it up. How do we set it up?
You're gonna do sine of A over A equals sine C over C, so that's sine of 22.5 over X times sine of 61.5
Okay, I'll call A or whatever. Okay, sine of 61.5.
over 30.
Okay? And so if we're solving for A or H or whatever you want to call it, wouldn't that be 30 times sine of 22.5 over sine of 61.5? Do people agree with that? Cross multiply and then dividing both sides by sine of 61.5. You're doing this on your calculator.
Got an answer.
What'd you get?
13.06.
13.06, do people agree with that? All right, so that would be the height of the tree, 13.06, so it's about 13 feet, but of course it's at an angle. Are we okay with this? All right. Now, in example 1 and example 2, you saw that 2 angles and 1 side determine a unique triangle. All right, because both of those, I gave you 2 angles and 1 side, or you were able to find out 2 angles at the side. However, what if we have 2 sides and 1 opposite angle are given? If that's the case, then there are 3 possible situations. This is called the ambiguous case, because it's not clear, just from before you dive into it, it's not clear whether there's going to be no triangle that fits that criteria, 1 triangle that fits it, or 2 different triangles possible. All right? So, instead of seeing page 432, I have something for you. a little closer look at this ambiguous case. Okay. So we're kind of investigating whether no such triangle exists, one triangle exists, and so on. So let's take a look at this little activity. It says, in the sketch below, you are given, need one? You are given a triangle with side length A, side length B, and angle A, where A is an acute angle. Note H has been drawn in. You're like, what's H? Well, H is going to be the vertical height across from that angle to get to side B. It's going to be perpendicular, all right, to side B. And notice, if I'm calling this H, then we know that H, if I did the sine, you know, from SOHCAHTOA, the sine of angle A would equal what over what? Danny?
H over B.
H over B, opposite over adjacent, H over B. So if I wanted to solve for H here, I could multiply both sides by B, and then I would have H equals B times the sine of angle A. All right? Okay, file that away. All right, so how many triangles are possible if side A, which has to be the side I'm going to draw in, right? I don't know if it's going to look like this or if it's going to look over here. It's going to be coming across from here, right? But if it's going to be less than H, if A is less than H, then how many triangles are possible? Well, if side A is less than the length of H, you know what, let me try this a different way. All right, so let's say that's side A, all right, but is it long enough where it's actually going to reach this side? No. So is there a triangle possible? Can I make a triangle if this little side here, this is side A, if that side A is less than H? No, it's not possible to make a triangle. So if that's the situation, there's going to be no triangle possible. Does that make sense? Okay. So what about number 2? How many triangles are possible if side A has a length equal to H? So now, what if my side A, which is the side, come on, let's try this again. So if I have the side A and it's exactly equal to H, right, then I'm trying to rotate this and get it to hit this segment down here. How many places is it going to hit? Just one place, right there. Everybody agree? So if that's the case, there's only one triangle, and it's going to look like this, right? Where this is side A, it's equal in length to H, it's across from angle A, and so on. And then this little side, this side here would be C, right, side C, and this angle B, what do you know about angle B in that case? It's a 90-degree angle, right? That's only if A was actually equal to H. Let's take a look at this next picture. How many triangles are possible if side A is greater than B? So let me try this again. I need my side A, something like this. I want it to be, wait, it's greater than B? Let me compare how this is. All right, so I need it to be greater than B, right? All right, so how many places can I have this hitting the line here? Just one, like maybe out here, for example. Agreed? So there's only one triangle possible if side A, here's my side A, is actually greater than B.
Wait, but
Jacob?
Yeah, couldn't you make side A a little bit longer because it's still greater than B?
Yeah.
And then
You can make side A as long as you want it to be, but we're keeping this angle fixed, and we're keeping side B fixed, right? And sure, you want this long, sure.
Yeah, well,
it's
I
just
guess
gonna
we go
get,
out there.
but there's only, but let's say it's, I'm
That's
playing
different
around
size.
with a certain length, and I'm saying, what if side,
Oh, with
let's
the
throw
same
some,
length.
yeah, let's throw up some numbers. Let's say B was 10, and A was 12, for
Got
example.
it, got it.
Then how many places will it hit? Only one place.
I thought
And I
you were
would have,
saying overall, like, if it's at all bigger than.
no, we're not gonna be playing around with different lengths. We're saying, what if side A was a specific length, and that specific length was greater than B's specific length? Does that make sense? So only one triangle possible, and it would look something like this. Everybody agree? All right, what else? Sketch the triangle possible. I did that. All right, let's look at, are we on number 4 or 5?
4.
4. So how many triangles are possible if side H is less than A and A is less than B? That means I want side A, if I can draw this again, I want A to be a little longer than H, right? But I want it to be less than B, so something like this, right? It's less than B, but greater than H. You with me? I'm trying to swing it so I'm not changing the length as I'm swinging it. So how many different triangles are possible if that's the situation? I'll throw some numbers on if you think that'll help. Let's say B is 10, and let's say H is 6, and let's say A was equal to 8. So that's in between the H and the B, right? So how many, rotate for me. There we go. So how many places can I fit? How many places will this hit this line so I can say, hey, that's a triangle? Danny?
Isn't side A side H? If we're doing the opposite of the angle.
Side A, whoopsie, side A was only equal to H in this first case where it says A has this length equal to H.
Okay.
That was the only time. And when we did that, it turned out to be a right triangle.
Okay.
We said in this case, if A was greater than B, which means it's way greater than H, but it's also greater than B, there's only one triangle possible.
All right, so in this one, we determined that side A was that bottom side.
Side A is always this thing that I'm swinging around here.
Oh.
This is always side A. Whether I said, oh, it's less than H, there was no triangle possible. If it was actually equal to H, there's only one triangle possible, and that means it's a right triangle. If it's greater than B, and I swing it around, there's only one place for it to hit, so there's one triangle possible. But now we're investigating what if H was 6, B was 10, and A was in between those lengths, like, oh, come on, I'll be like that. Little, sure, be that way. I just want, there we go. Okay, so if it's 8, how many ways can it hit? Can it hit over here? Will that be one triangle? All right, let me kind of lock this in place right here. So that would be one triangle possible. I'm sketching over that triangle. You with me? Could I also, let me slide this out of the way for a minute. Could I also swing this same guy over here and have it hit over here? Yes? Agreed? So let me trace over that one. That one's going to look something like, we're talking about this triangle here. Everybody agree? So these two triangles that I'm trying to trace over have the same initial conditions. Both of these triangles have, I'm going to make up an angle for A. They both have, let's say, angle A as like 35 degrees, for example, right? So I slide this over. They both have this angle A as 35, A as 35. They both had B was length 10. You with me? But here, that was side B, that's angle B here, this is angle B here, and then they both have this third side as, what do we say, 8? But it's two different triangles possible. We'll talk about this more after lunch. Which means I should pause the video. Okay, so as I was saying, we have these two triangles. That angle A is the same in both, side B is the same in both, and side A is the same in both, but there's two different triangles possible. So in other words, angle B is going to be different measures, right? This one's going to be obtuse, this one's going to be acute, Angle C is gonna have different measures, right? This one on the left is gonna be so much smaller than the one on the right. And obviously side C is a lot smaller here on the left than it would be here. Everybody agree with that?
Wait,
Still two triangles possible.
so then how does that like work then? Because isn't, if sine of A over A is the same, then how is sine of B over B?
I'm glad that you asked that. We're gonna take a look at some examples. So let's take a look at this situation here. All right, and with this, it says determine how many triangles are possible for each situation. If there is no triangle possible, show why. And if one triangle is possible, solve the triangle. And if two triangles are possible, solve both of the triangles. So in this case, we're told that A is 59 degrees, side A is 4, B is 14. So let's set up using the law of sines. So I get sine A over A equals sine B over B. And so I have sine of 59 degrees over 4. And I don't know what angle B is, so I have to write sine of angle B over 13. Everybody agree? So when I'm trying to solve for sine B, I'm going to cross multiply. And when I do that, I get 4 times sine B equals 13 times sine of 59 degrees. And I want to divide both sides by 4. So I get sine of angle B equals 13 times sine of 59, that's supposed to be 59 degrees, over 4. Grab your calculator, and we're going to do 13 times sine of 59 degrees over 4. 13 times sine 59, is that right, 59 degrees? Is that correct? Over 4. And when I do that, I get 2.786. Are we okay with that?
Yeah.
Okay, so 2.786, let's go back to our page here. So that means the sine of angle B is 2.786. So go ahead and find B. How do we find angle B? Danny?
Convert to degrees.
What's that?
Convert to degrees.
Well, this is just the sine of the angle, so we need to find the angle itself.
Oh.
Hannah?
Use the inverse sine.
Inverse sine. So would you please do sine inverse of 2.786? So I'm just going to do trig sine inverse of, and I'm going to just do control the negative button. Do you know that? It just pulls up the answer. You don't have to retype it, right? Control.
I got a no solution.
Well, what's up with that? I get a non-real result. Did you get an error message?
Yeah.
Why?
Because you can't, the domain,
What do you mean the domain?
like the inverse sine function cannot, like, it has the domain of negative 1.
Okay, so that means this part right here, this number, whenever you're taking the sine inverse of something, this number has to be between -1 and 1, right? Because the sine values always stay between -1 and 1. 2.786 is way too big. So we're going to say not possible. So since we can't find angle B, that means there's no triangle possible. No triangle possible for this first example. Does this make sense? Let's take a look at the next one. This time it says angle A is 58 degrees, side A is 4.5, and side B is 5. So let's set this one up. We want sine of 58 degrees over 4.5 equals sine of angle B over 5. Did I set that up okay? We're going to cross multiply and solve. And so I'm going to divide both sides by 4.5. And we're getting that the sine of angle B is equal to 5 times the sine of 58 degrees over 4.5. What are we getting for the sine of angle B? Is it a number between -1 and 1 this time? Augie?
Or a quicker way of doing that, instead of, like, this goes back to, setting it up.
Yeah.
Sine of A over A equals sine of B over B.
Yes.
You just multiply the B on both sides, and then you get it.
However you want to do it. However you want to do it. And so in this case, we're getting sine of angle B is what, Josh?
0.826.
0.826. Do people agree with that?
I got it.
No.
I got it.
Yeah. Some people say 0.942. All right, let's try this. So we're doing 5 times sine of 58.
Oh,
Control divided by 5 times sine of 58 degrees. Hit my degree button over, what is it? 4.5. I'm getting 0.942. Are we okay with this? All right, let's go with 0.9423. 0.9423. So go ahead and find angle B by doing sine inverse of 0.9423.
Got it.
What did you get?
1.2294.
Okay, 1.2294, but that's what units?
Radians.
1.2294 radians. Can you convert that to degrees? By multiplying by 180, divided by pi. Danny?
I got 70.
70. Give me,
0.44.
70.4.
let's give me one decimal place.
70.4.
70.4 degrees. Do people agree with this? Are we okay with this?
Yeah. So what does this equal? This is our B value?
This is our angle B. So let's recap what do we know about this triangle. We know that A is 58. A equals 58 degrees, and I know that side A is 4.5. Slide this down, slide this down, slide this down. Right? So, and I know that angle B is 70.4 degrees, and side B was what? 5. I don't know angle C, right? And I don't know side C. Cat falls off every day. Okay, so here's my, go ahead.
I was gonna solve for the angle.
Okay, go ahead.
You get angle sum theorem.
Okay,
So you just add 58 and 70.4, and then minus that from 180.
all right, so what does that turn out to be?
51.6 degrees.
So this was what, 128.4? And what'd you get?
51.6.
51.6. So do we agree that 51.6 degrees would be angle C?
Yes.
Okay, and how would we go about finding side C, Alexis?
You sine 58 degrees over 4.5 equals the sine of 51.6 over sulfur.
Over what? Over C?
Or C.
C, and then solve for C. So go ahead and do that. So we get C times sine of 58 degrees equals 4.5 times the sine of 51.6. And we're going to divide both sides by sine of 58. Does that look right? So at this point, these divide out, and we're left with C equaling 4.5 times the sine of 51.6 degrees over the sine of 58 degrees. Do you all agree on what side C should be? Gracie, what'd you get? What is it?
4.158.
Let's just give one decimal place. So 4.16. Let's go with 4.2. Are we okay with 4.2? Okay, so that means this is 4.2, right? But wait, I got to back up. We got B is equal to 70.4 because that is the angle that has a sine inverse of 0.9423. Agreed? But let's picture the unit circle. Picture, draw it up here. So picture the unit circle, and if I have this line right here, this is the line y equals 0, right? And if I shift this line up a little bit, like right now it's like y equals like 0.5, right? And if I have it go all the way up to the top of the unit circle, that would be what? Y equals 1. But really, our y value that we found was 0.9423, right? So it's a little bit further down. My unit circle is very, very fully drawn. Disappointed. Anywho, so we found one angle here, right here, this angle that measures 70.4 degrees. Is that the only angle that has a y coordinate of, I don't know what the x is, but I know that the y is 0.9423. Is there another angle that has a y coordinate of 0.9423? Augie?
Would it be 160.4?
Where are you getting 160
I added 90 to say.
You're adding 90? That's going to put me over here maybe.
Or maybe, hold on.
Not that one?
180?
Oh, no.
Jacob?
It'd be kind of almost like if you reflected that point across.
So like over here, like reflect?
Yeah. Like
So over here, okay, so we want this angle, and how do we find that angle? Sure,
Oh, it's
so,
109.
what is it?
109.6.
109.6, how'd you get that?
I subtracted 90 minus 70.4, and then.
So we're talking about this angle right here?
No.
Right?
90 minus 70.4.
You found a middle point.
I don't think we want 90 minus 70.4.
No, so I subtracted it, and then the difference of that I added on to 90.
All right, how about we just say 180 minus 70.4? Don't we want the supplement? We want the supplement of this angle. So here's my point, and it's a good one. It's very important for us. That I'm going to call this the alternate B, not to be confused with alternate facts. Okay? Danny gets it. All right. Alternate B, okay, would be 180 minus 70.4, right? So that means I would have, let me clear this out. That means I would have A still equaling 58 degrees. B now could equal, what was it? 109.6. C is going to be different, right? And we're going to have a different A, well, no, same A, right? Same B, but we would have a different C. Agreed? Now, this only works, that this alternate B would actually be a real possibility for a different triangle if there's still room for an angle C. In other words, C still has to be a positive angle measure. If these two angles are already greater than 180, then all bets are off and we only have one triangle possible. Does that make sense? But if we still have room for an angle C and still going to be a positive angle, then this is our second triangle possible. What do you get for angle C? Did you add these two and subtract from 180? Would you do that, please?
How do you know if there's an alternate angle again? Kind of threw me off. Like, how do you know if there's an alternate?
Well, the alternate angle is going to be,
12.4.
what is it going to be?
12.4.
12.4? Do people agree? So since 12.4 is a positive angle measure for C, then you're going to have to go one more step and find the alternate C, right? This here is triangle number 2, and this one here was triangle number 1. That's what the triangle number 1, right? So there's two triangles possible. Why did we have two different triangles? Because there's two different angles that have a sine of 0.9423. All right. Okay, so I'm glad we got through that example at least. You have that worksheet that I gave you that says, I mean, it doesn't look like the ones I make. I got it from a book. It says Law of Sines worksheet, right? I'm going to ask you to do some of the problems in there and some of the problems from the book. Please check the Blackboard for that assignment later today. All right? And stop.